In this video, I will show you how you can write a C# class with the CodeX application and how you can use a script to run and test the code that you have written. In this demo, we will open a range image, typical 3D vision range image from a mobile phone. To have a better impression of how it looks like, I'm going to visualize the C values with a rainbow color map. And what we will do in this demo is just measuring the height of these steps in a very simple way. So usually for an inspection program, you have a reference from a CAD model or from a reference scan, and then you define some reference positions and parameters that you use in your inspection program for the scans. So this is the reference scan that we use, and we define the positions where we want to inspect here. So I'm just using interactive point picking on this. When you have a CAD model or when you have some values from your customers, some positions, you can use those. But for now, for our purpose here, it's sufficient to use those picked points. Now that those points have been created, I'm just converting those single points to a point cloud, and I'm renaming this point cloud to top points. So this is it for the reference object. Now imagine we have the scan, and the scan is already aligned. So I'm opening the scan, already aligned. And now we want to inspect the scan. So how does it work with a C# class? I'm creating a new class. And let's call this class evaluator. And we add a method, static method returning double, and we call it measure step. The input is a range image for the scan data, a 3D point, a vector 3D for the top position of the step, and a double value for the delta X, delta Y, and delta C. That tells us how far should we move from this top position to the area where we want to measure the bottom. So let's say the top point is here, and we want to move 1.5 millimeters along the -c direction to this area, and there we want to measure the bottom. So this is what we do. We create the point that we use for the bottom. Bottom equals top plus a new 3D vector delta X, delta Y, delta C. Now this is the point on the top, on the bottom, and now we project those points onto the scan. So the top point is becoming a scan projection of top, and the bottom is becoming a scan projection of the bottom. And this function returns the C difference between those two. Top C minus bottom C. So this is a very simple program to measure a height. It's only using single points, and in a real-world application you might use something more robust, using some selections, some smoothing, averaging, outlier removal, or whatever. But for our purpose now, that's sufficient. So let's say this is the function that we want to use. And now I'm creating a script, and the script will now get the data from this script context here and provide it to the class and run the class code. So we get, first thing is we get the scan, which is a range image, and the name in the context of this is phone scan aligned. And the points that are our reference points on the top, it's a point cloud, context get top points. Now these are the objects that we use, and now we run through all the top points. and we call the evaluation function. So we say double step equals evaluator measure step. Remember, that's the method that we defined in the class here, in the evaluator class. So the point on the top is our top points index I, and first parameter is the scan top points, and then we have minus 1.5 millimeters along X, and in Y and Z we keep the same coordinate. So this is the height at this position, and in the first step we are just printing this to the console and log it. So we say the step is to string 3 digits. Okay, now let's see if the program compiles and runs. So we compile and we see no errors. So imagine that you made some syntax error. Let's say we have here something like this, and then we check if it compiles, and then we get the error. You see here in class 1.cs line 13 we have an error. So we go here, line 13, and we fix it, and then we check it again. Yeah, compilation is fine. So we can run it. And to run the script, you can press F5 or you can use this menu. And then, as we see, the script is running, and the console output, which is shown here in this window, it gives us these values, these numbers. So it's somehow working, but now to be sure that the results are correct, we need something to visualize what we did. And so for visualization, we add something to the context, and this is going to be a new line, a line segment. So let's say step number I will be a new line segment from the top point to the top points indexed I plus let's say height of the step multiplied with the C unit direction, M vector 3D C unit. Now this gives us a new line segment, and I'm just running it, and as you see we get this. Yeah. So now, summarize, we have a new class which is called evaluator with a method that returns a double value, and we use the script, and the script is just receiving the data here from this context and providing it to your class, and then visualizing results in the IDE, the CodeX application, by adding it to the context. So everything that is added to the context is automatically visualized in this IDE. So this is a nice way to create some reusable source code that you can use in your application directly. So this one, it has no special things. It's just plain Metrics library code, and you can use scripts to provide data to your classes and to test and visualize.